Hello everyone. Now in this video we will see how to draw a isometric view of a solid from 2D view. Here you can see on the screen, these are the two-dimensional view of a solid. So this is the front view and this is the top view, orthographic projections of a solid. So from these orthographic projections we need to construct three-dimensional solid. As we know that using the isodraft isometric view, we constructed isometric views, isodraft mode F5 by rotating, by shifting to isoplane right, isoplane left, isoplane top. So by using that method we can construct, and we can construct the isometric view of a 3D object by one more method in the AutoCAD. So that is nothing but, you can see here, in generally we used to draw projection of lines, projection of points, everything in this drafting and annotation layout. But when to construct three-dimensional solid objects, AutoCAD gives you this option, 3D modeling. So to construct three-dimensional objects, move to 3D modeling. So when you enter into 3D modeling, see the complete toolbars, everything changes here. So this is the modeling tools, and this is the editing tools and meshing tools, draw tools, modify tools, sectioning, coordinates, view. So these are different types of tools are present to draw the 3D solids. Okay. So now the important one is that view. You just see here, defaultly it will be an unsaved view, and top, bottom, left, right, front, back, and these are the two-dimensional views, and these four are the three-dimensional views. The top 6 are the two-dimensional views and the bottom 4 are the three-dimensional views. You will come to know when we go for drawing about all these things. And here these are the styles of drawing, we will come to know when we will go for drawing an solid, that means constructing a solid. So now we will go to the first question. So before going to the question, we know that we have to set up the units. It's in millimeters, precision I am making it to 2, and limits A4 size 0, 0, landscape na 297, 210. Yeah, now the sheet is ready for drawing. So first you can see that, so this is the orthographic, means two-dimensional, and we have to construct three-dimensional, 3D. As we know that every projection and every construction we made it in first quadrant. So above the reference line will be the front view and below the reference line will be the top view. So this is the solid, front view of a solid, top view of a solid. See, when you see the question or a drawing, we need to find out how many features and how many objects are there in a solid. Here this is the first solid, this complete angle plate is L plate is a first solid, and this portion is the second solid, that is why we represented with the dash. So this solid we are going to remove it from the 1, 2 is removed from the 1. When you see in the top view, see this complete portion is the first object, and this portion, a rectangular block, is the second portion. So when you remove this rectangular block from this one, you will get a rectangular hole. So that is why it is represented with the dashed lines. Now we will construct the same in the AutoCAD. So this is the front view, right? So first we will construct the front view, and before going to construct the front view, first calculate the each and every dimension. Here you can see 65, 15. What about this dimension? They are not given, but here you can see this dimension is this one 15, because top view 15 this portion. So 65 minus 15 you will get 50, and this one complete height is 45, already 15 is there. So 45 minus 15, this portion is 30. In the same you can see here 65, 15 up to this portion 50, from here to here 30, 15, 45. So to construct the front view, all the dimensions are here, and the same the top view we need to calculate each and everything. So total is 65, already 10, 30, 15. So 40 plus 15, 55. So 65 minus 55, this portion is 10. Already here it is 40, the center portion is 20. 40 minus 20, 20. So remaining 10 and 10. So now we have clear dimensions of each and everything. So first we will start constructing this one. AutoCAD, as I said, first I will choose front. Yes. Now I will take the command polyline, as we know that ortho 65, 15, 65, 15, the one is 50, 50, 50, and this one is 30, and this one 15, and now 45. Yes. See, now the front view is ready. The front view is ready, and now after this one we have to give this thickness of the solid. This 40 is nothing but thickness of the solid, which can be viewed in the top view only, which can be viewed in the top view. So the thickness of the solid is 40 mm. So how to give thickness? Present it is in a 2-dimensional view, so that's why you can go for 3-dimensional southwest isometric. So this is southwest isometric, and this is southeast isometric, and this is northeast isometric, and this is northwest isometric. So 4 types, I mean in the 4 directions you can see, but present for the sake of very clarity I am going for southeast isometric. Yes. Now we have to give the thickness of the solid. We have to give the thickness of the solid. How to give? So there is one option in the AutoCAD, extrude. Click extrude on the user interface, and it is asking select objects. Yes, select objects. Enter. See, as you see in the here, the thickness of the solid is 40 mm. In the top you can see the thickness of the solid is 40. 40. Enter. Yes, now the solid is ready. First solid angle plate is ready. Okay, but this is not sufficient to present, because we have to create this portion also. Second, here you can see that a rectangular hole is there. So to make a hole, first we will create a rectangular box. This is the top view, right? Here you have the dimensions. So 10 from here, 10 from here. So 10, 10, and then you have to construct this one. How to do? See, now I am choosing top. Yes, see, now this is the top view. Take the line command, 10, 10. Yes, see, highlighting. So this is 10, this is 10, and from now here you have to construct a rectangular plane. Polyline. What's the dimension of the rectangular plane? You can see that here 30, 20. Width is 30, 20, and the length is 30. So polyline 30, 20, 30, and then 20. Finished. So now again go for southeast isometric. See, we have a plane. So next extrude. either you can extrude using this interface or type the key AXT, extrude. Now I am selecting this rectangular plane, enter. When you give some thickness to the plane, it becomes a solid. What is the height? 15. Yes. Now finished. The thickness is 15 na? So throughout this one it's having, so that's why 15 I give. Now you can see here, when I am placing the cursor, only this angle plate highlights, means it is a individual solid. And now when I am placing the cursor here, only this highlights, means it represents one more individual solid. Now on the screen we have two individual solids, solid 1 and solid 2. This is a rectangular blocks and this is a rectangular, angle plate. But the thing is that in the drawing it says that this is a rectangular hole, not a box, because you can see these dashed lines, removed portion. So how to remove this portion from this one? In the AutoCAD we are having a command sub, subtract. When you type subtract and then enter, see here it is asking select solids, surfaces and regions to subtract from. So from this we have to remove this one. So I am selecting from this one, enter, and then it is asking to subtract. Which one we have to subtract? This one. Select this one, enter, finished. So now I am placing the cursor here. See the complete object highlighted, means the operation finished, subtraction operation finished. Now this is a complete solid. Now only one solid. So to view you can have different options. Conceptual view, see how best it looks like a solid, and a hidden, realistic, shaded with edges, shades of grey, sketchy, wireframe, X-ray. The X-ray is nothing but intricate details also you can see very clearly. So as of now I am using 2D wireframe. Yes, now this is a complete solid finished as according to the diagram. According to this one everything finished. But the thing is that in the realistic time we have to present which are visible and invisible edges. Here the lines are continuous lines, all the lines are continuous lines itself, indicates that everything is visible. But in the real time, no, this edge and this edge, everything are invisible, so this is not the way to present. So to present a perfect presentation of the drawing, go to the layout 1 or layout 2, anything. So now you can see that this one. So what I am going to do for the perfect presentation, here you just click on the paper space. When you click on paper space, now present it is in model space. When you click on paper, it moves to paper space. When it is in paper space, you will get the navigation bar, everything here. So I am selecting the pan command and moving this solid away. Yes. Now I am removing the grid. Yes, it's in paper space now. What I am going to do is that select the base from model space, See, when you click on model space, it shows like that. Just click it here, enter, click it. This is a 3-dimensional, click it, and this is a side view. Click it, enter. See now, perfect, everything is perfect. Front view, top view, side view. These three belongs to the orthographic projections, and this is the isometric projection. But the thing is that here this is not showing very clearly, and we didn't understand perfectly how the details are, because it's in southwest isometric. But the thing is that in the model we created everything in southeast isometric. You can see southeast isometric. Suppose southwest means it turns like this. In the layout we got southwest, but we made it in southeast isometric. For clear details, we need southeast isometric. Here southwest. How? So what to do is that just select everything, delete. Again base from model space. Previously I placed the first position here. So instead of this one, now I am placing it here. Enter. Here. Yes. Now you can see southeast isometric. Here side view. Enter. Yeah. Finished. But the thing is that in the question already they gave the orthographic projections. From this orthographic we need to convert 3D. So what I am going to do is I am going to keep only 3D, no need of this 2D. Side view, front view, top view, I am deleting it. This 3D is enough. I am keeping it to center. Yeah. But this drawing looks very small. So to make it big, what I am going to do is that double click. When you double click, here you can see this is called scale. 1:1, 1:2, 1:4. It's a scale. See, this is 1:1. Whatever you draw, one the same portion will represent here. Suppose if you want to make it smaller, 1:2. See, it reduces. And the same if you want to reduce still 1:4. 1:5. See how low it go. But if you want to make it bigger, then go for 2:1. See, two is to 1. I mean you are making it to double time, 2:1. But here it crosses this one. Click. Yes. Perfect. Now the view is ready. But one more thing is that here everything looks the same color. As we know that in the last tutorials we used to give different colors for the object. I mean red color we used to give for visible edges, everything. Here what I am going to do is that I am going to give one color for the visible edges and one color for the invisible, I mean hidden lines. So to do that one, just click on the layer properties. See, when you click on the layer properties, you can see hidden lines, visible lines. Default colors are white, I mean black color it will represent. So what I am going to do is that for hidden I am going to select blue color line, okay, and for the visible I am going to select red color. You can select whichever you want. Yes, see, immediately it changes to hidden lines to blue color, visible lines to red color. Already the line weight for hidden lines is 0.35. For visible lines the line weight is 0.5, but it doesn't shows here. So we have to go for activating the line weight option. We saw in the two-dimensional projections, there we will go to layer properties, line settings, display line weight option, but here it is difficult. So what we are going to do is type LW, line weight. Now click display line weight. Okay. See, immediately it changes to, I mean it highlights, it applies the line weight to the present diagram. Once finishes, we have to remove this one. Again click on the layer properties. Yes, it disappears, the layer properties. Now it's perfect. It's time to give the dimension, dim aligned. So each and every dimension is important. Yes, but the see here, as we saw that this is 65, 15, 15, 50, but here it shows 53.07. As we know that here it gives the perspective projection. So to represent it here perfect dimensions, double click 65. You can modify 65, and this is 15, and this is 40, and this is 30, 15, and this is 20, and this is 30. Dim style will increase the text. Dim style, modify text, I will give 5. Okay, yeah, now it's perfect. Okay, dim edit will make the dimension parallel to this one. Oblique, select this one, enter, so to this one. Yes, now again oblique, enter, yes, oblique, yes. Now every dimension we give, but here you can see that exclamatory mark, dissociated annotation. So to overcome this one, just click paper, it will disappear. Yes, see, it disappears. In the present it is in model space, we can't move. Again click it here, bring it to down. Yes, make it closer. Now again one more thing, give the text. It is 6, 0. You can write your text like this. Click on the paper. Now the exclamatory marks vanished. Now, yeah, one more thing I left, we can see line, in the paper space, line, dimensional, angular. See, 30 degrees. Again, say 30 degrees. Click on the paper. See, Now you got perfect thing. You have to give this dimension in model space and then click paper. See, now this is the perfect, represents a isometric view. 65 are these dimensions and these two are the isometric view. Now export PDF. ISO solid desktop I am saved.